Afternoon. I am the J.A. Dad. Thank you for stopping by. Welcome back. Today marks day 2 or episode 2 of me just having fun coding, learning to build a game. The goal of this is to eventually build something a little more meaningful in the next 30 days or so and have a little bit of accountability with me having to log in and code and spend some time with it on a daily basis. So I'm capturing my journey here on YouTube. I appreciate those that are joining me in this, whether it be through commenting, subscribing, liking, chatting, coding along, learning something. Join me. It is genuinely appreciated. I love being around like-minded folks. I think iron sharpens iron. But anywho, give me a moment. We are going to jump in and get started in just a second here. Today was it's been a pretty good day thus far. Was able to wasn't completely off work today, but didn't have to spend a whole lot of time in work today, so that was a good thing. Got a little scare, but I should have mentally prepared myself considering the source. But nevertheless, got a little mental scare that wasn't that turned out to be a false alarm, but just something we just need to be aware of. So I am thankful that it turned out to be nothing more than just a little scare. But anywho, we're gonna get started in just a moment here. Wow, didn't even know realized my microphone wasn't going. I'm sorry about that. But let's redeem ourselves. Wow, I did not know that. God almighty. All right, so let me do this. So before we actually build the game, the first thing we need is somewhere to draw it. And I'm using the HTML canvas element for our game board. Canvas is basically giving JavaScript an area on the web page where we can programmatically draw things like shapes, text, characters, and eventually our obstacles. It's giving the canvas a width of 400 pixels and a height of 550 pixels. And the CSS is really just positioning it in the center of the screen and giving us a dark background. Then there are two important lines of JavaScript. First is document.getElementById, passing in or looking for the ID of game. This is going to find the canvas element in our HTML. This is going to find the first is document.getElementById, and we're looking for the game element. And we're going to find this. This is going to find the canvas element in the HTML and store a reference to it inside of the canvas variable. Then we'll call canvas.getContext, looking for a 2D. You can think of the canvas as our piece of paper and CTX as the tool we're going to use to actually draw on the paper. There's nothing really happening on the game just yet, but now we have the foundation, we have our game, the board, JavaScript can access it, and we have the 2D drawing context we'll use to put things on the screen. Next, we're going to work on creating the actual player. So we currently have the game board in place. The next thing our game needs is a player. But instead of creating a player as a regular object, I'm going to introduce a JavaScript class. The easiest way for me to think about a class is a blueprint. Class player doesn't actually put a player onto our game. It's going to describe what the player should look like when we eventually create one. So inside of this class, we have a constructor. The constructor is going to run whenever we create a new player. That's where I'm setting the player's starting properties like its width, its height, position on the X and Y positioning. That's where I'm setting the player's starting properties like its width, height, X position, Y position. And you'll notice I'm using quite a bit. And with this, you'll notice that I'm using it quite a bit. In this context, I could think of this as referring to a particular player object. So this dot width is going to mean the player's width, and this dot X means the player's X position. For the X position, I'm taking the center of the canvas and subtracting half of the player's width, then put the entire player in the center instead of putting its left edge in the center. And for the Y positioning, I'm using the canvas height, subtracting the player's height and another 30 pixels so the player sits slightly above the bottom of the game. If I refresh the page right now, nothing is going to appear, and that's actually important that we've created the blueprint for the player, and that's actually important. So far we've created the blueprint for the player, but we haven't created an actual player for the blueprint just yet. Let's work on doing that now. All right, man, I didn't realize the doggone thing wasn't going. I'm sorry. I had to redo that. But we should be good now. I think this one is 22. So let's name it O2 voice. Oh, yep. And then we'll bring this into this. Bam. We're good there. In the last step, we created our player craft. In the last step, we created our player class, but nothing appeared on screen because the class is really just a blueprint. Now we need to create an actual player from that blueprint. Before doing that, I added a method to the class called draw. A method is basically a function that belongs to an object or a class. The job of this method is pretty simple. The job of this method is pretty simple. Whenever we draw gets called, woo, I can't talk. Wow, good grief, struggling today, man. All right, so let's try this again. The job of this method is pretty simple. Whenever we draw gets called, use the canvas drawing context to draw a rectangle using this player's X position, Y position, width, and height. Then underneath the class, I use new player. This is the part that actually gets created. This is the part that actually creates an object using our player group. Man, I'm struggling today. Let's try that again. This is the part that actually creates an object using our player blueprint. This is the part that actually creates an object using our player blueprint, and I'm storing that object inside a variable called player. Now the player has all of the property. Now the player has all of the properties that were established by the constructor, and it also has access to the draw method. So when I call player.draw, JavaScript is going to run that method, and our player finally is going to appear on the canvas. And there is an important distinction here that I'm trying to understand as I'm learning classes myself. The player is the blueprint. Player is the actual object. Player is the blueprint. Player is basically an object created from the blueprint, and draw is something that the object knows how to do. Right now, it's just a square sitting at the bottom of this screen, but next we're going to give it some life and make it move. Man, the struggle is real. We can actually move that there. And I think I'm good here. Let me grab that. 20 seconds. Like that. All right. So to make it move, we're going to use some keyboard inputs. And I'm gonna do this. Do that. We'll do. I think event.key.to lowercase, and this is going to be equal to false. I think to the player class we just need to add the speed. So we'll go inside of this. Better if that's there. This dot speed is going to be equal to 7. That's good. Oh yeah, it's pretty good. I got no complaints. Things have been going pretty good, man. How about with yourself? I appreciate you stopping by. Just continue to do what I do, continue to stay engaged, and go from there with it, man. But yeah, things are good though. I have no complaints. So now that we have a player, we need some way for the player. Now that we have a player, we need some way for the person playing the game to actually control it. To do that, I created an empty object called keys. The purpose of this object is to keep track of which keyboard keys are currently being pressed. Then I'm using something called an event listener. A key down event happens whenever the user presses a key, and JavaScript gives an update object containing the information about what happened. From that event, I can use event.key to find out which of the keys were pressed. So if I press A, I'm essentially storing keys A as equal to true. Then I do the opposite with key up. When I release A, the value becomes false. This gives our game a way of continuously knowing which controls the player is holding. I also added a speed property to the player class. So every player we create now knows its own width, height, position, and movement speed. Nothing moves yet because all we've done is just collect the player's input. So the next step we're going to do is connect the input to our actual player class and actually change the position. So that is going to be a little fun. So let's go ahead and work on that now. All right, so basically we're just going to give this player class a new attribute. And we'll say if keys, and I said A, or keys, and we'll go arrow, ARROWLEFT, left. This dot X, we know that that's going to move it on the X. It's going to be minus equal this dot speed. And we'll say if keys D or keys arrow right, this dot X plus equals this dot speed. And then the thing I think we need to do now is call this. So I think it makes more sense to put this inside of a game loop. What happens if I just go player.updates? And nothing just yet. So let's do this. Let's create a function named game loop. CTX. Let's do this. Let's go game loop. Request animation game loop. CTX dot right. 0, 0, canvas dot width. Canvas dot height. Player dot updates. This should be player dot draw. Now let's test this thing out. There we go. And as you can see, we have life. All right. Now we finally connect the keyboard input to movement, and I added an update method to the player class. The purpose of that update is to handle anything about the player that can change while the game is running. If A or the left arrow is being held, I subtract the player's speed from its X position, which moves it to the left. If D or the right arrow is being held, I add the key. If D or the right arrow is being held, I add speed to the X, which moves it to the right. Then I create a game loop. The loop first clears the previous frame, then updates the player position, then draws the player again. Finally, request animation frame tells the browser to run the loop again on the next frame. So the basic pattern is update the game state, draw the results, and repeat. That's really the heartbeat of the game. I think this is just sec. Files, throw this in here. Oh, let's do this. Whew. Hope everyone's doing pretty good. Let's see here. What do we have next? So I think next we want to stop the player from moving off of the canvas. Let's do that. Do that. If this dot x is greater than 0, is equal to 0. If this dot x plus this dot width is greater than the canvas width, then this dot x is equal to the canvas width minus this dot width. Awesome. Now the player moves, but there was previously an obvious problem. You could move completely off the board. So just added some boundaries. On the left side, that's simple. If the player's X position becomes less than 0, I reset it back to 0, meaning that it won't go any further than 0. The right side is slightly different because X represents the left edge of the player. So I added the player's width to its X position to figure out where the right edge is. And if that right edge goes beyond the width of the canvas, I move the player back to its right. Its right side lines up exactly, excuse me. If that right edge goes beyond the width of the canvas, I move the player back to its right side, which lines up exactly with the edge of the board. So this is another example of how the game programming often comes down to tracking positions and checking whether positions are still inside valid boundaries or not. Little things that you don't pay attention to in the beginning, but once you're playing, you absolutely will notice if your player is able to go outside of what should be the boundaries of the board. So glad we got that fixed up and taken care of real quick. Do this. So I think I need an obstacle now. And that's going to be its own game. And we'll create the game object for that. So we'll start with the class and then we'll move on to the actual update, but let's do the class first. Let's start a new one. Loop this dot y is equal to negative this dot height. And this dot speed for this will be 3. And I think for these we'll need to draw the obstacles and I'll make them red. So we'll do the draw method. CTX. Class obstacle, and this will be a constructor, and we'll go this dot width will be equal to 30, this dot height will be equal to 30, which is just setting the size of the item. And then I wanted to have a random position, so on the x we'll set this dot x equal to math dot random times the canvas height. Well, let me go width first. Width minus canvas dot height. Then we'll go this dot y is equal to minus this dot height. And we'll set the speed to be equal to 3. So that cares for the actual model or the foundation of the obstacle. Now let's draw it. So we'll go draw outside of that constructor, of course. And this will be ctx.fill_style. The color for this is going to be red. And ctx.fill_rect will be this.x, this.y, this.width, and this.height. And the color underneath this will go const obstacle step code is equal to new obstacle. And then finally to draw it, we'll just go obstacle dot draw. Mm. Mm. It's odd. I wonder what am I missing here? Hey, what's going on, my brother? How you doing, my friend? How you been, bro? I know why. I have this thing. What if I change this? There. Yep. Okay. Just want to make sure. But I have the starting position of it above the screen, so that makes sense. I appreciate it, man. Thank you, man. I'm trying to do something every day, having a little fun with it. Um, gonna make something a card game in 30 days in the end of the month, but I got a long way to go before I get there. So just trying to understand the patterns and how this works and graduate from vanilla HTML and JavaScript to something a little more powerful, if you will. But for right now, it's fine. It's fun. It's something to do. What have you been up to, man? All right, so we've created the thing the player needs to avoid, and I'm using another class called obstacle for this because eventually I want to have a lot of these objects on screen at the same time, and each of these have its own width, height, position, and speed. So for the X, I'm using math.random to give every obstacle that can start a different place across the top of the canvas. And I'm also getting the Y position slightly above the screen, so you use a negative value, which is Y. When I remove it, you can see it. That way, once we start moving the obstacles downward, it will enter the visibility game area instead of just appearing in the middle. And that's basically all it is to create the obstacle. Now let's do the actual obstacle update or movement so that it has some movement on screen. Let me do that now. Nice. I kept that one pretty simple. I think I just added score to it and some auto update functionality. Nothing crazy with it, but I do plan on doing things a little more complex over the next 30 or so days. Just having some fun, nothing that requires a whole lot of mental stress, if you will. But that's cool though, man. I don't think, did I build any games with Java? I know I built a lot of text-based conditional type things and a little bit of data structures, but not a whole lot of games with Java. I think by the time we got deep into it, we jumped into Spring Boot, and then I think the professor just kind of let us run with it because most of us that were in the class were web dev enthusiasts using class. So what are you doing? Oh yeah, man. Well, it's all good. At least you know what to look for and know how to get what you're looking for. Yeah, this is a longer way to get something done, but it's all good. I enjoy it, so keep me out of trouble, if you will. What have you been up to lately, man? Um, all right, let's do the move down first. That should be. So I think that is. Gotcha. Where have you been finding work? Are you doing anything in your local community, in your local area, or has everything pretty much just been online? I have another buddy that I met on social media, in fact, that just started a agency. He uses Fiverr. Didn't seem like he from what he shared, not a lot of movement with it, but he did get one nice client from it. Local businesses. Yeah, I think that's probably the best route to go, man. Is if you can get your foot in the door with a local business, considering the proximity of competition, you know, you're probably their only or their best option, if you will. And so it makes a lot of sense to tap into local businesses versus trying to do something where there's so much competition. Because a lot of times, man, if you can go inside and shake someone's hand and put a face with a name, that goes a long way, especially if they get the feeling that you are ambitious and somebody that's easy to work with. So I've had more success with local businesses than I've had online too, to be honest with you. In fact, I think I was telling you the other day, my first opportunity was because I knew someone that could help me from a local business, not necessarily me just putting my name in the hat and a recruiter finding me and getting the interview and going from there. But that's what's up, man. Yeah, man. As much as I like to code and like to help people, man, I don't know if I can do something for someone professionally for that wage. To each his own. And I know some people, you know, that's all they can bring in, and you know, I wish them the best. But I'm with you, brother. I need a little more than that, man. That doesn't go a long way, especially for the for what I feel the amount of effort and amount of work I put into it. I need a little more compensation than that to keep me motivated. Otherwise, I'm gonna be tapped out pretty soon. That's gonna move it down. So player update. Let's do my. And we see we have a falling star or a falling object. Nice. Let me see. Will I press this enough? Will one collide with it or no? All right, so that was pretty simple. So all right, so we got an obstacle so far, and to make it actually fall is what we ultimately wanted to do. So I gave it a class of its own and an update method, and inside of that method, just adding the obstacle speed to the Y position in Canvas is going to look at Canvas starts at 0 and at the top of the screen, and Y gets larger as it moves downwards. So increasing Y moves the object or the obstacle towards the bottom, and the lower the number is, it's going to move it towards the top. It's basically the same pattern we're using for the player. So first we update where the obstacle should be, then draw it at the next position, and then the browser is going to repeat that process in the next frame. What I thought was interesting is that both of the objects now follow the same basic structure. The player knows how to update and draw itself, and the obstacle knows how to update and draw itself. So that's the good thing at this point. I think the next thing is to establish an array or a bunch of obstacles so that we can get more random objects or obstacles, I should say, falling down. And I know I got to fix that collision too, but we're just going to take this thing one thing at a time. Likewise, my brother, I appreciate you stopping by, man. Always good to see you, man. Or nice to get to hear from you, I should say. All right, so let's do this. And we'll go with sec 08. Is that code? Oh man, so I think for this, we just need to do something simple where we create the objects or create an array for the objects, push those objects into an array, and then map over that array and use update to update each of the objects in the array. That should be the flow for that one. So let's do this. We can do let's go const obstacles. is equal to an empty array. And then to add those obstacles, we'll go obstacles.push. And this is where we'll use the new obstacle. I'll just be sure to call it. And I think we should be able to remove this one. Yep. So for that, inside of the updates, we can go remove this and go obstacles.forEach, which is a JavaScript method. We'll go function obstacle and go obstacle.update. So for each of those obstacles, we're calling update. And then I think we just need to draw them on screen. So we'll replace this. Go obstacles.forEach. Go function. That's an obstacle. And this is just going to simply be obstacle.draw. There. So to test this thing out, okay, so we need a way to create additional obstacles, but just to kind of talk through what we have right now. Up until this point, we've only had one obstacle, but the game eventually needs a lot of obstacles on the screen at the same time, and creating a separate variable for every single one wouldn't make much sense, right? So instead, I'm going to create an array called obstacles, and every time we create a new obstacle object, we can push that object into the array. That means the array becomes a collection containing all of the obstacles that currently exist in the game. But this also changes how our game loop works, right? Instead of updating one obstacle, I use a for each to go through the array and tell every obstacle to basically update itself. Then I do the same thing when we draw. What's interesting here is that we're combining two concepts. The class gives us a reusable blueprint for creating obstacles, while the array gives us somewhere to keep track of all the individual obstacles we've created. Right now, I'm still manually adding them to the array. The next step is where it starts becoming like an actual system where we're going to make the game automatically create new obstacles over time. And that's when it's going to start to kind of really feel like a real game, so to speak, when we have more obstacles being displayed on screen at once. So we're going to work on that next. Oh man, that's pretty cool. Let's go with this. And what do we have here? Let me check something else out. Man, I need some good dinner ideas. I'm not sure what I'm having or what I want to have. All right. All right, so we need a way to automatically create obstacles. So let's do this. We'll go with a spawn setting and do it like that. So let's do let last spawn 0 spawn delay equal 1000. So let me do okay, let's go with spawn object. We'll pass in time. All right, let me finish this out. So for the spawn object, we're going to say if time minus last spawn is greater than spawn delay, then we want to do obstacles dot push. We want to push those into the array, and we're going to use the new obstacle object to represent what goes in the array. And then we'll need to update last spawn to equal time. And then for the function game loop, we're going to pass in time. And we instantly get raining obstacles. All right, now we have an array that can hold multiple obstacles, but up until this point, I've still been able to. Now we have an array that can hold, oh my goodness, I can't speak this evening. Jeez Louise. Now we have an array that can hold multiple obstacles, but up to this point, I've still been manually adding them. For the actual game, I want new obstacles to continuously appear on the screen. For the actual game, I want new obstacles to continuously appear over time. So I'm introducing two variables, last spawn and spawn delay. Spawn delay tells the game how long I want to wait between obstacles, and I'm using 1000 milliseconds, which gives me roughly one obstacle every second. Then I'm using timestamps provided by request animation frame. Then I'm using the timestamp provided by request animation frame. I can compare the current time against the last time an obstacle was created. If enough time has passed, I create a new obstacle and push it into the obstacles array. Then I update the last spawn with the current time, which basically starts the countdown over again. Now the game isn't manually creating individual obstacles. Now the game isn't manually creating individual obstacles anymore. We've built a system that can continuously generate them for us. And because each one is created, oh my goodness, I can't talk, man. And because each one is created using our obstacle class, every new obstacle gets its own position, speed, width, and height. This one is 17. I need to do collision now because hey man, what's going on, Snowman? Just making a little collision game, some JavaScript practice, getting some hands-on practice with building games, and decided to do this. Nothing fancy. How you doing, my brother? I appreciate you stopping by, man. It means a lot. JavaScript, plain old vanilla JavaScript. Yep, nothing fancy with this one. Where you stopping in from? You don't mask me. If you don't mind me asking. Um, so we have the obstacles falling. Next, I need a collision detection, and I basically just created a reusable function named collides that basically is going to serve as the way that we can detect if a collision took place. So instead of asking whether two objects have the exact same X and Y position, I'm going to check their edges. If the left edge of the object is before the right edge of the other object, and the same true for vertically, then the rectangles are overlapping. For now, I'm not taking any health or anything like that away. I'm just going to do a collision. So this is basically just some simple code to detect whether the edges of those items align. And if they do, then we know we have a collision. And then from there, we'll do something. But for right now, that's just the function to see what we have. So the next thing is to actually test this function out and see if it actually works. It should work, but if not, we'll make some minor tweaks to it. But it shouldn't be. It should work. Ba, 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 ba. Oh man, this has been a productive day thus far. So we need to do collision detection, and that should be some if then statements, right? Yeah. So let's do function draw lives. Let's go function draw lives. That is equal to 20 pixel area. CTX dot text align equal to the left. CTX dot field text. That allows dot lives, and we need to create that in the player object. The problem right now is I just need to set up collision detection. So I have a function to create collision, but I need to set up detection. And part of that, I need the player to increment every time a collision takes place. I want the number to decrement. So they'll start with 3 lives, and every time that player gets hit by an obstacle, the lives are going to decrease. So every player is the player class or model is going to start with 3 lives, and every time a collision takes place, a life is going to be removed, and then once those 3 are gone, you won't have any lives left. So that's how we're going to make sure that the collision detection is actually working, by setting up a lives method and removing a life each time a collision takes place. Hope that made sense. And lives. All right, so this should be in the game loop, and I have for the obstacles, basically what we want to do is inside of the obstacles, for each, we're going to draw one, and I want to map over each. So why don't we do this? Why don't we just remove the current, and let's start over. So we'll say for loop versus a for each. For I is equal to obstacles dot length minus 1, and as long as I is greater than 0. I wonder how many folks greater than or equal to 0 actually remember that I actually remember how to write a traditional for loop if you're using JavaScript. With so many methods out there right now, it's easy to forget. But const obstacle is equal to obstacles dot I, and then we want to update or call obstacle.update so we can make the update on the screen. And then basically we'll say if collides player, because that's the name of the object, player and obstacle, we want to take away a life. We'll go player.lives, take away 1. And I could log this to the console just to be sure. We'll go lives. And then we'll go lives. Well, this is just for the terminal, for the console. So player.lives, just to make sure. And then, we'll need to splice. So obstacles.splice and 1. All right, so I see them actually hitting and not going through the player anymore. But what I do need next is to draw the life on screen. And why do I have transformed opponent? So for this, let's go draw lives. So I see 3. And you see it is going down, but I don't want it red. Why do I have it red? CTX field white. There we go. And you see it is going down. And let's just get hit again. We see it goes to 1. So the collision detection works. Awesome, 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 awesome. Basically, wasn't a very complicated process. Pretty much kept it simple. But now that the collision detection works, I want the collision to actually affect the player. So we added a life property to the player. So I'm adding a lives property to the player class, and starting at 3. When an obstacle collides with the player, we're going to subtract 1 from that value. I'm also removing the obstacle from the array immediately after the collision. That's important because the game loop runs many times per second. And if I let that obstacle And if I left the obstacle overlapping the player, it could subtract multiple lives almost instantly. That's the reason you see it kind of disappear as soon as it hits the player right there. This also gives me a reason to introduce spike. This also gives me a reason to introduce splice, which lets me remove a specific item from the array. Lastly, I'm drawing the player's remaining lives directly onto the canvas so that our game state is visible to the person that's playing. And at this point, collisions don't just exist mathematically, they actually have consequences. And as you can see, I'm getting hit quite a bit. So let's add some additional functionality next. I think the next thing is let's add game over. I think it'll be important to know when the game is actually over. Oh man, what's going on, man? Just today. I just started with it today, man. But to be honest with you, I started learning it yesterday. Yeah, so I just started, man. I was following there's some MDN documentation on the canvas element, and I just kind of went down a rabbit hole from there of trying out some of the hands-on tutorials that it had, and then just kind of thinking of different little games that I can come up with to reinforce the learning that I was getting from the tutorial. And then ultimately, building upon a couple different concepts each game or each time around. So it sticks. I'm having a little bit of fun, getting some instant gratification with the hopes of building something a lot more complex in the next 30 or 45 days or so. Yeah, appreciate it, brother. Man, lock in with me, man. Follow my journey and would love to hear from you, my brother. Where you stopping in from? You don't mind me asking. How do we go right here? It will go let's game over or false. So I think we need a function to do for game over. And we'll need to clear the canvas. We'll need to say that if the game is over, to update the player. And we'll need to notify or put a message on screen that the game is over. All right, so let's do that. Let's draw game over on screen. So define typical start field text. Over. Canvas that move. It's 2. No canvas that height. 2. There. All right. So in the game loop, we need to make an update as well. We'll say if game over, we want something to happen. Yeah, let's do that. Man, what in the world? All right. Let me remove this. Keep all of that. And then the game loop, we're gonna retype this. We'll say if game is not over, we want player.update to be on screen. We want spawn. Let's be AWN. Name it spawn object or obstacle? I did name it object. Okay. I equals 0. No, we're not going to do that. We'll do obstacles dot length. That's 1. And as long as I is greater than or equal to 0, decrement I. She don't need that there. We'll go const obstacle is equal to obstacles at the I index, and then we'll go obstacle.update to bring it to life. And it will say if collides, and we're passing in the parameter of player and obstacle. Go player dot lives, and then we'll go obstacles dot splice. We'll say if player dot lives is greater than or equal to 0, then game over is equal to true. And then from that, we'll go right here, we'll need player.draw. I'm going to go obstacles.forEach. Call a function. Pass in the obstacle. Obstacle.draw. And then we'll say if game over, draw game over. All right, so that works, but I don't see the live. Yeah, it'd be much easier in Python, and I've actually started back doing a little bit with Python, to be honest with you. So I'll probably do a little bit of coding with that in the upcoming days or so. But you're right, it would be easier with Python. And I've been coding JavaScript, to be honest with you, for about 5 years or so now, maybe 6. Yeah, Python makes things a lot easier. But just for me, man, I actually enjoy the coding process. So sometimes I don't mind typing or doing some of the ground level work because I just enjoy it, especially if it's something that's a hobby like this. If it was something for a client, I'm absolutely with you. I'm going to use the most efficient approach that makes the most sense to get the job done. But because it's like this, I don't mind little bit of extra work. Mm-hmm. Let me see, CTX. Do I call this anywhere? Draw lives. That's part of the problem is I don't call it anywhere. I probably should call this somewhere in here. There. Now let's play. There, it works. Game over. So, now that the player can actually lose lives, we need the game to understand when the run is over. So we added the variable called game over, which starts at false. This is another example of game state, right? The game needs to know whether we're currently playing or whether the current player has already lost. Every time an obstacle hits the player, we reduce the lives by 1. Then I check whether the number, just to make sure I ain't going crazy. Yep. Every time the player hits the obstacle, we reduce it by 1, so that's good. We know when it is over. The important part is that I'm using the value inside of the game loop. So when the game over is false, the player and the obstacle continue updating. When it becomes true, we stop updating the gameplay. I still keep the drawing of the final frame, even though I still keep drawing the final frame, even though when I draw over the dark overlay with game over message on top of it. So that's why it appears like this. So we've separated the two ideas of updating the game and drawing the game. And the game can stop and change, and it works perfectly fine at this point. But I think it'll probably be a little funner if we included the actual score. So I think what we'll do next is add the actual score for the game. Let's do that. Ooh, ooh, ooh. Move that over. Move that over. Let me see something. What is that? Ba-da-ba-ba-ba. What do I want to add next? Let's add the score. That's what I want to add next. That way you can see the score. Okay. Let's see. I put the darn thing, but okay. Let score. Let's start out at 0. Player obstacle. Let's go here. Function. Draw score. So let's do this. Uh-oh. Where did I write that at? There. Okay. So let's do it here. Let's do draw score. All right, so we don't see anything yet. That's fine. I have goofed something here. Hold on. Duh. I had to set the dot down. All right, so now we just need, now that we have it drawn, I must be tripping. Let me see. What am I doing wrong? What am I missing? I think I need to. I don't have a word for. Let's see something. My obstacle update. Let me see if I can not find this thing updated at. There. What's updating on the collision? Mhm. I did. I missed this thing. Let me see something here. Okay. Whoa. That ain't what I was expecting. All right. I I'm trying to blank right now. Let me add this. There we go. No, it's not. I was putting it. I forgot to write a. I put the score incrementer in a place where the collision would take place with the player. When I wanted it to be, if you avoided the collision, you got a point. So, and I was forgot to write the function to or the functionality in order to do that, the if statement. So was drawing a blank there for a minute. That's what took me so doggone long. But yeah, thanks for sitting through that one, man. That one was pretty rough, but we're good now. So just to kind of summarize that a little bit, um, you basically just want to give a visual to the player, an incentive for them to stay alive as long as possible. So we added the score, right? Fixing something that isn't as obviously visual, but it matters on how long the program actually runs. So an obstacle moves below the actual canvas, so we don't need that object anymore. And if I wanted every obstacle inside of the array forever, the game would keep track of the obstacles that can no longer affect anything on the screen. So when an obstacle's Y position goes beyond the height of the canvas, I remove it from the obstacle array. Because the player successfully avoided the obstacle, you're going to add a point to the score, and then we draw it on the screen in the top right corner of the screen, and that introduces another important idea, which is cleaning up the objects after they no longer need it. So I could probably come back and do that. That'll just help with the memory and the overall functionality, but did want to explain that to make sure I understood the logic behind it, not just be able to write it per se. Um, mm, mm, mm. I think let's do a difficulty incrementer. Basically, once your score gets to a certain point, it increments. Um, so we can create a variable named loop, create the function, and from there increment the difficulty if the user is successful. basically in the same spot, we're going to update the score. Yeah, let's do it. It shouldn't be too complicated. All right. All right. Basically, I like to create things that I could actually use or solve a problem. I wouldn't say solve a problem, but I could actually use. So one of the things we like to do in my household is play games, and we like to compete. So one of the games we like to play is a card game called Uno. So I figured that, hey, it would be pretty cool for fun just to build a card game playing Uno, and I can put an hour or two a day into it. So from there, I realized that I didn't know a whole lot about game development. My comfort zone is with web development. And so decided to see what it kind of took to build what it was that I was looking for. So it may eventually require me learning a different programming language, which I'm fine with that as well too. But for right now, since I'm primarily studying cybersecurity and this is just something that I want to do for fun, I figured I'd do a little web-based game. So starting with JavaScript, and that's how I landed in the MDN docs, learning about Canvas and going through the little tutorial that it had. And then from there, just trying to reinforce what I'm learning and like learning some of the main things that I need in order to play the game. So I know I'll need some form of a AI style logic. I know I'll need, of course, the interface. I'll need to eventually add multiplayers inside of it and things of that sort. So for right now, just starting with the basics, going through the documentation, reinforcing my learning, struggling with the things I don't know. And as I get more and more comfortable, excuse me, introduce more and more concepts to what it is that I'm doing. And then just keep reinforcing what I'm learning and just finding little ways to practice. But because it's like something that doesn't have any like a real deadline or a real timeline on when it needs to be completed by, I'm really just taking my time with it. But it's been kind of fun. I started yesterday, and of course I have some coding experience, so a lot of this stuff isn't foreign to me. It's really just trying to understand some of the coordinates and how that worked. And I did do some game development with Python, but not a whole lot, not enough to where I would say I knew what I was doing. But there are some lives from like 2, 3 years ago where I've done it, but just kind of using that, reinforce what I'm learning and just going from there. I think today I'm adding score and game over and stuff like that, where yesterday I didn't really have those features. Basically, the foundation is just about the same, where you start with the class character. Excuse me, you start with the canvas, you start with the class character, you give the character the ability to update. Once you've done that, you create whatever type of action. Yesterday, it was being able to hit a ping pong ball. So I needed the ability to add soft keys and recognize the update. And then from there, create the collision, set the boundaries, and that's pretty much it. So this is pretty much the same concept. The big thing is instead of trying to hit a ball, you're avoiding the ball. And basically just reverse what it was that I did yesterday. And then today, adding in the ability to keep track of score, game over, and may add a little more of a difficulty to this so that as the level goes up, the difficulty goes up. But that's basically it. So I came up with the idea and how I landed where I'm at right now with it. You do any game dev or do any coding at all? If you don't mind me asking, what is your niche, if you will, in the coding world? All right, so we will do the level at the top. And then we will do we need to increment the level, but let's draw the level first to keep the same format. So we'll go function, draw level. ctx.fill style is equal to white. And ctx.font is equal to 20, which is error. And ctx.text9 is equal to center. And then we'll go ctx.fill text. And this we want level. So 11. Number 2. Let's spin the lobby 30. More web development. Gotcha. What stack do you use? If you don't mind me asking. So let's do a function. To update difficulty. Using the level. And then we'll do obstacle speed, which I need to add that. So that would make the game faster, the obstacle speed. Oh yeah, yeah. I have web development is it's kind of my comfort zone. It's what I started out with, and it'll probably be what I do forever. I enjoy it. It's a creative outlet and it's fun to do. But yeah, I do web development. In fact, I was going to probably do a full stack application today. I had someone ask me about doing a connected MongoDB and Mongoose to a Next.js app, so I was thinking about doing it later on this evening. But yep, what what tech stack do you use for web development? Where is the obstacle? There we go. Yeah, so this worked out. This is basically what I was looking to get accomplished. Now that the player has a score, I'm using that score to let it control the difficulty of the game. And I'm creating a level system where every 100 points increases the level. When the level increases, I increase the obstacle speed and reduce the delay between the obstacles. So the longer the player survives, the faster the obstacle fall and the more frequently they're going to appear. I'm also putting a minimum on the spawn delay so the game doesn't eventually try to create an absurd number of obstacles every frame. What I like about this is that the game isn't using separate levels or like maps where taking the same core mechanics and changing a few variables over time to make the experience harder. This is a good example of how relatively small changes in a game state can completely change how the game feel without having to do a whole lot of work. Yeah, hit one on accident. Today I wanted to see if I could build a small JavaScript game completely from scratch. Nothing crazy, just HTML, Canvas, JavaScript, and a simple idea. Move a player across the bottom of the screen and try to avoid falling obstacles. I started by setting up the canvas and grabbing its 2D context. This is basically what gives JavaScript the ability to draw differently onto the screen. This is basically what gives JavaScript the ability to draw different things onto the screen. From there, I created a player. Whew. Man, if I could talk. From there, I created a player class. The player itself. From there, I created a player class. The player itself is really just a rectangle with a width, a height of X, and a Y position and a movement speed. The player itself is really just a rectangle with a width, a height, a X, a Y position, and movement speed. Then I added a keyboard control. Then I added keyboard controls. Then I added keyboard controls. I created an object that keeps track of which keys are currently being pressed and use A and D or the arrow key to change the player position. One thing I had to account for was the edge of the screen. Without boundaries, the player could just keep moving completely outside of the canvas. So I added a couple checks to prevent that from happening. Once the movement was working, I moved on to the obstacles. Created another class named Obstacle. Then I created another class named Obstacle. Each obstacles I created another class named Obstacle. Each obstacle starts slightly above the screen and gets a random X position. Then on every frame, I increased its Y position. And because the Y increases as you move down the canvas, that makes the obstacle look like it's falling. But one obstacle isn't much of the game, so instead of managing them individually, I created an array that stores all of the obstacles currently in the game. And then I built a spawning system. Every certain amount of time, JavaScript creates a new obstacle and pushes it into that array. Now I have multiple objects falling from a random position across the screen. The next challenge was figuring out when one of these objects actually hits the player. From that, I created a collision detection function. Basically, I'm comparing the boundaries of two rectangles and checking whether they overlap. If the obstacle overlaps the player that's hit, if an obstacle overlaps the player, that's a hit. I gave the player 3 lives and every collision removes 1. I also removed the obstacle that caused the collision. Otherwise, because the game loop is running over and over again, the same obstacle could potentially register multiple hits. Then I added a score. Every time an obstacle makes it all the way past the player and leaves the bottom of the screen, I remove it from the array and add 10 points. That automatically solves 2 problems. The player gets a reward for successfully dodging something, and the game isn't keeping hundreds of old invisible objects in the memory. Finally, I wanted the game to get harder instead of feeling the exact same forever. Finally, I wanted the game to get harder instead of feeling exactly the same forever. So I added a level system. Every 100 points increases the level. When that happens, the speed of the objects increases and delay between obstacles gets shorter. So early on, the game is perfectly manageable, but the longer you survive, the faster everything starts coming at you. This project ended up being really good. And this project ended up being a really good reminder that even a tiny game can bring together a lot of programming concepts. And in this project, I use classes, objects for the player, and obstacles. Ooh, if I can talk. I used classes, and this project ended up being a really good reminder that even a tiny game can bring together a lot of programming concepts. I use classes and objects for the player and obstacle arrays to manage multiple game objects, event listeners for the keyboard input, functions for collision detections, state for lives, score for levels, request animation frame to keep the entire game running. And there were definitely there were definitely several bugs along the way. I had an obstacle that wouldn't appear, collision logic that wasn't behaving correctly. And at one point I had a difficulty system that technically existed, but I never actually called a function, which is pretty much programming. But by the end of today's session, I went from an empty canvas to a small playable JavaScript game. And tomorrow I'll figure out what we're building next.